Okay, so this video is the multiple choice section of the NMSI packet for linear momentum and impulse. So what I expect you to do is, as you go through it, wait till I read the problem to you, be following along, pause the video so you just don't hear the answer. Okay, so make sure you pause it, try to do it, and then listen and watch the answer to see if you got it right. So because if you just listen to it and write the answers down, you're not getting anything for it. Because remember, this is basically studying for your exam. Okay, so let's get started for that. All right. So number one says this: two objects of mass 3m and 4m are initially at rest on a horizontal surface, frictionless horizontal surface, sorry. An ideal spring is compressed between the two objects, which are held together by a thread of no mass. After the thread is cut and the spring is released, the object with a mass of 3m has a speed v. What is the speed of the object with the mass of 4m? All right. So pause it here for a second, try it, come back. All right. So what we're going to do is draw up the two different scenarios, right? So we should have two carts together. I'm not drawing the spring. You know there's a spring between them. This has a thing of 3m, and this has a thing of 4m. And then the spring goes, and then the 3m1 goes this way, and the 4m1 goes this way. All right. So hopefully that makes sense. All right, so let's look at this. So we're going to do this. Momentum initial equals momentum final. Well, think about it. What's the initial momentum? The initial momentum is 0. Nothing's moving. And then I have two carts moving independently. So I'm going to do mv for this. So 3mv plus 4mv. All right. And that all is good. There's my equation. So now all I have to do is solve for, so they're going to be traveling at different velocities. So I'll make this a capital V just so we know that that's the one we're trying to solve for. And then you just solve. So I'll subtract. So I get negative 3mv equals 4m. So I divide by 4m, and v will equal 3/4, because the masses cancel out. My answer here is B. All right. Pretty easy, pretty straightforward. Conservation of momentum problem. All right. Next. Question number 2 says, a 10 kilogram block moving to the right with a speed of 4 meters per second on a frictionless surface collides with a 5 kilogram block also moving to the right with a speed of 2 meters per second. If the blocks stick together upon impact, what is their new speed? Okay, so pause and then come back. All right, so here's what we're doing. Same thing here. We already have a picture drawn for the beginning, so let's just do it for the after. 10 kilogram and the 5 kilogram are going to be combined, and they're going to move together. Pretty easy here. So if I do this, I do momentum initial equals momentum final. Conservation of momentum problem again. Initially, I have m1 v1 plus m2 v2 equals m1 plus m2. I'll make it capital because we don't know that. That's one we're trying to find. So I plug in. I got 10 and 4 plus 5 and 2, and I got 15 times v. So if you solve that, you should get, what do I get? 3.33. So that gives me an answer of B right there. All right. That one. Question number 3. So it says, in a demonstration, a physics teacher throws an egg at a blanket. Oh, that's crazy. Maybe I did that in a fake video on your lecture and just talked about it. and it does not break. When the same egg is thrown at a brick wall, it breaks. Which of the following best describes the egg's change in momentum? So pause here. Think about what change in momentum is. Okay. So let's think about this. The mass is going to stay the same. The final velocity is both of 0, and you're throwing it with the same initial speed because it's whatever you're throwing it at. So in this case, the change of momentums are going to be the same, even though the egg survives in one piece. All right, so the answer there is going to be C. Number 4 says, a 2-kilogram ball traveling eastward at 3 meters per second is kicked in such a way that it is now traveling westward with a speed of 8 meters per second. The impulse applied to the ball is this. So let's draw it. So this is key. Really, the only thing that makes this difficult, or how you get it wrong, is if you forget your frame of reference here. So I have a ball coming in this way. A ball gets kicked and it goes out this way. This way is positive. This way is negative. Okay. So if I look at this, it says, what's the impulse? Remember, impulse is equal to change in momentum. So all I have to do here is impulse is equal to mvf minus vi. So if I go here, J equals mass is 2, Vf is, because it's negative 8, because it's going this way, and 3. I have to do negative 8 minus 3. So I get J equals negative 22. Right? 4 is D. Yeah, so I got it. Good. All right, perfect. Next question. Question number 5. You just had, so this one, I had to read it twice, so just make sure you read this carefully, okay? So we have this situation here. It says an object of mass m and speed v, so it's talking about the one on the left, collides with a second object of mass m traveling to the left with a speed of 2v. They are both traveling on a frictionless surface. If they collide and stick together upon impact, they will move off with a new speed of, okay. Oh, wait, this is no, never mind. This one's easy. Sorry. So I was thinking ahead. All right. So this is, so my after, so let's draw my after. They're going to move together. We got to figure out which way it's going to go and stuff like that. So let's do our momentum initial equals momentum final. I have capital MV plus 2, oh, yeah, well, it's 2 MV equals, they're going to add them together. So I got M plus M times a new V. And it wants the new speed, so I solve it for this. So I basically, well, my common factor I can pull out because it looks like they pull out a common factor of V. So if I pull that out, I got M plus 2M equals M plus M over, or times V. I just divide here. And that's how I solve for that. Oh, that, undo that. That's stupid. So there is my answer. And it looks like it's C. Oh no, I made a mistake. It is D. And why is it D? Oh, I forgot my frame of reference. Positive, negative, right? So if this one is positive, this one has to be negative, and that's why I have to do this here. So I messed it up. There you go. So that's why it's D. All right. Remember, frame of reference has a velocity. Questions 6 and 8 have to do with this. This is a force versus time graph. All right, so number 6 is pretty straightforward, pretty easy question here. It says calculate the impulse to the mass during the first 25 seconds. So pause it and then come back and we'll do this together. All right, so Remember, impulse is the area under the curve. So all I have to do is make a little thing here. So this area is a rectangle. So area here is 4 times 10, which equals 40. And then the area here is a triangle. So area equals 1/2 base, which is 10 to 25. So 15. Height is 4. You get, what do you get here? Oh, I don't know what you get here. I have to do it. Oh, no, you get 30, right? Yeah, you get 30. Stupid. Half times 4 is 2. 2 times 15. I was trying to do it half of 15. So half of 4 is 2 times 15, so it's 30. So my total would be 70. So 6 is A. Yeah, so I got A. Sorry. 7. All right, so we know the impulse here. We know the impulse is 70, okay? So we got to keep that in mind for 7. If the object had an initial velocity at time equals 0, so at time equals 0, we know its initial velocity was 3. We want to know what its final velocity would be after this. Well, what we have to remember is, did they give me a mass? Yeah, 7. So it gives me a mass. I thought I needed that. Yeah, I do. All right. So remember that impulse equals change in momentum, right? So I know the impulse equals 70. Well, change in momentum is equal to mass velocity final minus velocity initial. I'm looking for velocity final here. Well, I know my mass is 7. My velocity final is what I'm looking for. My velocity initial was 3 meters per second, so minus 3. And now I can plug in and solve. I divide by 7, that gives me 10 equals VF minus 3. So I add 3, I get VF equals 13 meters per second. Is that it? Yep, C. All right. Pretty easy, pretty straightforward. All right, so the last one, it says, what is the acceleration of object during the first 10 seconds? So if we look at the first 10 seconds, it has a constant force of 4 newtons, right? So this one's pretty easy. It says force equals mass times acceleration. We had a constant force of 4. The mass is 7. I need to find the A. So I divide, so I get A equals 4/7 meters per second squared. B. All right, B. Okay. All right. Keep on moving here. Number 9. A circus performer is shot out of a cannon and flies through the air until landing harmlessly in a net. Which of the following best describes why the performer is not injured after his death-defying event? Pause and think about it. Pause and think about it. All right. I don't know why I started waiting. You have to pause it. So the answer here is going to be D. It says the net increases the amount of time of the momentum is changing and decreases. So that's what basically the same thing as the egg in the blanket, right? That the net gives away, it increases the time. So if you increase the time, the force is going to decrease to keep the change in momentum, and then the impulse the same. So that's why you get that smaller force, because it increases the time it takes to stop. Number 10. Okay, so this is the one that you got to read carefully here because it kind of threw me a curveball. I had to read it twice. It says object A has a mass m and velocity v. Object B has the same mass but with a velocity v. So they have the same masses, so we can represent both with m. If the magnitude of object A's momentum equals the magnitude of object B's kinetic energy, what is the second object's velocity in terms of v? So basically, I pause and go try it. All right, so here's how you do it. So what you want to do is really focus on this last thing right here. If the magnitude of object A's momentum, so in other words, m times v, equals the magnitude of object B's, 1/2, and kinetic energy, mv squared. So this is the v we're looking for, and we want it in terms of this. So if I solve this, yeah, so I solve this, I would get, what I do, 2, so multiply and divide, so I would get 2v equals v squared. And then I would get, oh wait, it's capital V. So what is V in terms of, yeah, so that's square root, right? So my answer here is going to be B. All right. Hopefully that was useful and helpful. Hopefully you tried, make sure you should have tried to do that before just listening. Again, because this is a review for your exam. And hopefully that was pretty straightforward. All those problems are pretty much straightforward, easy problems. All right.